Hi everyone, just thought we'd make a quick video just to go through some of the NDT methods on the 2850 content level 3 for MMA, MIG and TIG. And we're predominantly going to look at the radiographic testing today. Tony here has kindly agreed to talk through some of the processes with us, being our in-house welding inspector. Thought it'd be great to get you on board and just have a little chat with you today, Tony.
Yeah, I'm looking forward to it, James. Yeah.
Thank you very much. So, just a couple of questions really about the process itself. Starting with when a welder comes in to do a test and things, what is the actual stages, what is the process of the welder approval tests? Could you just talk through that a little bit?
Yeah, so when we use the word welder approval, you can see there that we're trying to approve a welder according to something. So that's exactly what's happening. A welder comes in to do a test with the desired effect of reaching the criteria of set standards. The standards in mind, we've got a sort of BSEN 9606, ASME 9, and what they do is they contain the rules basically for qualifying welders or welding procedures. So what must be done in order to prove that this welder has the capability and quality to work on a specific job.
And it's specific because of that weld procedure specification assigned to that one job, is that right?
Yeah, that's a big part of it. Will be issued WPS, which we'll test in accordance with, yes.
Yeah. Brilliant. So in terms of your role as a welding inspector, can you just give a little bit of detail about that when the test is being carried out? What's your role within that?
All right, so it's quite a large role actually. We have a great relationship here at Middlesbrough College with loads of companies, both locally and nationally. And part of my role is just keep liaising with those companies, letting them know we're here and what we do. They'll contact me. As you mentioned, WPS, I request a WPS for them, so I can see what the nature of the test will be. Check the material types, the consumables, could be carbon steel, stainless steels.
Right.
Have we got the right wire and such like that in stock? If we've got all of that in, then we invite the welder in, and my role then really starts is to witness the test.
Right.
So as James mentioned, I'll be witnessing the test in accordance with the WPS, welding procedure specification. So I'll be checking things like, is the right amperage being used, the right voltage, is the travel speed looking right, all those kind of things, visually examining as we go throughout, making sure the quality's there.
Just on that, Tony, could you talk through a little bit of the piece of equipment and the tools that you might use then throughout the visual inspection?
Yeah, certainly. So we've got some here actually, James. So, if we start at the early stages, so checking things like I said, amperage, voltage and stuff like that, using an amp or voltmeter for example. But once the welder starts welding, it's very important that we monitor the heat of the joint. So one of our roles is to use a digital thermometer like this one here, which gives me an accurate reading of the temperature. Right. So every time the welder stops welding, we'll need to wait for it to cool down to a certain point. It varies according to material. Before he starts again, so we need to monitor because too much heat can affect the material itself. So that's one thing I do in there. But before the welder even starts welding, I'll use a gap gauge such as this one, and I'll place that inside the root of the joint to check that the dimensions are set correctly according to WPS. So let's say that's 2 millimeters, which should be in accordance. A gap gauge, which we place inside there, just like that, and then we pull this up, and that tells us if there's a step between these two pipes internally, perhaps that we couldn't see, for alignment, to make sure that we've got the right gap and we've got the right alignment. That's before we even start. Once we're actually up and running, like I said, I'm just monitoring that, but then when the welder finishes, I'm going to use some other tools as well. I'm going to use a mirror and a torch, just like you get at the dentist. If you tilt that over a little bit so they can see it. I'll shine the torch in there so I can see the root. I'll put the mirror down so I can see the root in good detail underneath and everything. So it's a couple of tools I use during visual inspection.
At the moment you're just sort of looking at what maybe just the run profile itself?
Just at the profile, like you say, is it linear or straight, is there no undulations, no excessive penetration, things like this. Just checking on those at this point.
Brilliant, that's fantastic, thank you. So then, as I say, we're going to move on to radiography now, and the guys are going to have a task to do, which is all about radiography and interpreting some graphs and things. But before we get on to that, What is the radiographic process when let's say this weld has then left you and went to an external company? We use Oceaneering, don't we?
That's correct, yeah.
When it goes to them, what do they do with that then? What do they do with the weld test?
So once I finish in Oceaneering and get this delivered to them by me, it undergoes radiography, as you say. There's two types of radiography, X-ray and gamma ray. Both use the same principles, really.
Yeah.
So what we've got happening then is, to understand this properly, there's sort of three key terms that I'm going to introduce you to now. One's penetration, so we need to know that radiography penetrates through a material, radiation penetrates through a material. The next one is rectilinear propagation. That just means that when radiation does travel through a weld sample like this, it travels in a perfectly straight line.
Okay.
Right? And the third thing is something called the chemical effect. On a radiographic film there's an emulsion, and the radiation reacts with the emulsion on the film, changing it from white to black.
To give the image as such.
To provide the image. So if we consider this as a piece of radiographic film, I would place that behind the weld, for example. We will go into this in more detail shortly, but just for now, we can imagine that this is a radioactive source. It could be X-ray or gamma, as I say. We position that towards the weld. The radiation travels through the weld, passes through out the other side, and through chemical effect, change the emulsion from this white colour you see here to black.
To black, I see.
Yeah. Okay. So just quickly, just to give an indication of what that looked like, if there was a defect in there, like a crack, more radiation will get through.
Darkening.
Making it darker.
Right, I see, because more radiation is hitting the film.
Yeah, hitting the film, reacting with it. So if there was a crack, it shows a really dark line against a lighter background.
So, opposite to that then, where might the film be left bright, or would that be then if there's too much weld metal?
Exactly that, James, yes, exactly that.
Great stuff. Radiography process, I've had a little look at that. What kind of defects then can we... actually, before we go into that, you mentioned about the film there going into different directions. I know that you've got different diameter pipes here, big diameters here. Is it always the same process, or is it different?
A very similar process, but with a slight variation to it. So if I just move that to one side briefly, let's start with a bigger pipe to give you an indication of how we might do this. With a big pipe like this, I could fit radiographic film inside it.
Right, so if I just lift this up to see.
So I could pop that film basically inside there.
I see.
Like that. And then radiation, my radioactive source, will be placed in front of this wall here and pass through there and affect the film.
So that would just be going through one
so it's
single wall?
It's single, that's what we call it. We call it single wall, single image, because the radiation is passing through one wall, producing one image on the graph.
Okay.
Now, if you take on a piece of the half-inch from me there, James, what we'll see is there's no way I can get radiographic film inside such a thin pipe. So what we do in this instance is we put the radiographic film behind the test sample and the radioactive source in front, and we pass it through two walls, so it goes through the front, through the back and out there, and it'll print a graph. Now if I put the radioactive source directly in line with the weld, we would call that double wall. It's going through two walls, but because it's perfectly in line, it's only going to produce one image for us.
Of course, right.
We don't tend to do that because we like to see in more detail both sides. So if I offset the radiographic source and send the radiation through on a slight angle, what it'll do is catch the front of the weld and the back of the weld separately and produce an ellipsis like an oval, so we can see both sides of the weld quite clearly. So that one's called double wall, double image, because I'm seeing both sides of the weld.
Okay, that's fantastic. So in terms of, we've caught these images then, we've got them all on some films, and again, just grab that a second, these films are the types that will be produced, and obviously you can't really see them at the moment, they're just black images, but we'll put light behind them and you'll see that image. What kind of defects then would we expect to see on this process?
So when the learners in the classroom with you, James, use the light box to look at these things, you might see what we're really looking for is internal defects.
Yeah.
So obviously one of my roles, as I said earlier, was to visually inspect this thing. So if there's things wrong with the surface on the root, I'm going to see them. So I'm not really looking for them on a radiograph.
Yeah.
Things like undercut, which would show up on a radiograph. I would have already picked up on that.
Yeah.
So what I'm looking for is things inside the weld, perhaps porosity that hasn't broke the surface.
Right.
Things like excessive penetration, as you said earlier. More radiation will get absorbed, so the paper will stay white behind. So I'd see like a really white patch.
Yeah.
Too much weld. Incomplete penetration. More radiation is going to get through. It's going to show up a dark patch.
Right.
A crack, a straight line that would let more radiation through.
Yeah.
See a dark line.
Yeah.
And things like lack of fusion, sidewall, inter-run fusion.
Yeah.
All of these different things that you would expect to find inside a weld, really, volumetrically.
Fantastic. Thank you very much. And really, I suppose to finish with, I think is the advantages that you see with this process, maybe compare with others, and the limitations as well. What do you think of the advantages first?
There's a really strong advantage with radiography, and you've already sort of hinted at that. We get a permanent record of the test sample, so if there's any indications, if there is some like a fusion process or something like that, I've got a permanent record of it here, a physical representation of the weld itself. Now, if you compare that, like you said, to UT or something like DIPEN or MPI, what we'll have is a report that the NDT technicians wrote up that have found, but not an actual physical image of the weld. So this is a real big advantage.
A big benefit, isn't it?
Yeah, but again, there's a disadvantage there with that, with radiography. We can't actually tell the depth of the defect. So on this cross section of a pipe, if there's a defect indicated on a radiograph, it might be really close to the top or it might be really close to the bottom. I wouldn't know. I've got no real indication of that. So then we could couple it with UT, which will give us a depth indication.